let's talk a little bit about some topics. Now, don't forget, these are the automation best practices. These are things that myself and other solution architects have gathered over our 75 plus years of test automation experience. And so all of this is really important. So don't fall asleep, pay attention, because these are the things that will make or break your test automation efforts. And one of them is parallel test execution. Parallel test execution is extremely important, and it is critical to the success of any test automation effort. Without being able to execute tests in parallel, your automation efforts are doomed to failure. Parallelization is extremely powerful. Here's a case study of a suite that we transformed to use parallelization. We took a suite of 18 tests that were running in 20 minutes and 7 seconds sequentially. We've transformed those into 180 atomic small UI tests, and we ran all of those in parallel on about 75 virtual machines, and we were able to execute them in 3 minutes and 55 seconds. You can see that the test suite execution time here is drastically improved and drastically better when using parallelization. That's why parallelization is so powerful. Even better is if you do the calculation of getting average test runtime per test case in that suite. We went from 90, we had a 98% improvement. So the test basically went from running about 86 seconds per test on average to about 1.6 seconds per test case on average. If you take the 180 and divide them by the total test runtime, it comes out to about 1.6 seconds per test case on average. There is nothing, no technique in the world, no amount of code optimization that will get us such amazing test case runtime improvements as parallelization will. Some more examples of what is possible in the real world. These are real things that our clients are doing, and I'm only showing this just to make you excited, make you understand the power of parallelization. We have a client that's running 7,000 tests in 7 minutes. Now, that in no way means that you should be running so many tests and you should be running so fast, but again, just showing you the power of parallel test execution. Another one of our clients is executing 100,000 tests per day. Actually, I think at some point they went over 200,000 tests per day running in parallel, and then they realized that was way too many. They were having maintenance issues. They couldn't execute so much, so they are scaling back now, trying to figure out more optimized ways of running the test automation. But again, another pretty powerful statement showing that this is only possible with parallel test execution. There's no other technique in the world that will provide us such amazing results, that will provide us such fast feedback as being able to execute in parallel. So there are 4 mandatory requirements for parallelization. If you do not achieve these 4 requirements, you cannot run in parallel. Running in parallel is really easy with the tools, but it is not easy with test automation itself. The actual test automation code has to be written correctly so that you can run in parallel. And so the 4 requirements are: test must be atomic, autonomous, you must manage test data correctly, and avoid the static keyword. We already talked about atomic enough, so I'm going to skip over that one and we'll proceed to the next one. Autonomous tests are those that are self-contained and isolated. I don't see this happening too much where people are having non-autonomous tests, but there is still a misconception that you are allowed to link test case 1 to test case 2. And for example, once test case 1 finishes, test case 2 begins to pick up where test case 1 left off. That is not an autonomous test. That is an anti-pattern. Those are tests that are coupled together. And so if, for example, test case 1 fails, test case 2 will automatically fail as well, but not because there is a bug in the application. It will fail because it was dependent on test 1, as a result making the value of test case 2 useless because it's not providing you true results of the actual feature. So avoid linking your tests. Tests must have their own setup, their own teardown, and they must execute and provide a result, and no other tests must rely on the results of any other test. You also must have proper test data management. Test data management is key to having parallel test execution. Now, there is a very dangerous way of managing test data that will prevent you from being able to run in parallel, and that's hard coding your test data. This is one of the worst things that we can do, because hard coding test data means that we have to be able to know if our tests will step on the other test's toes. So look at all of these questions that you have to answer, right? For example, maybe you had one test that executed and modified the state of some object, maybe some user in your database, and then another test was relying for that user to be in state A, but test one turned it into state B. And now when the test runs, it fails because you have invalid test data. In that case, your test will fail. You will not be able to run in parallel because all the tests will be stepping on each other's toes, and the test will not be able to reliably use test data. The best technique to use here is called just-in-time data management. And see what I did here, just in time. Now you see this beautiful face of Justin Timberlake. You're never going to forget the just-in-time test data management system. All it really means is that you want to have an API or some way to create your test data before you execute a test, utilize that test data inside of your UI test, and then destroy it afterwards. We always want to be cleaning up our test data so that it doesn't affect anything else. It doesn't fill up our database, or it doesn't accidentally make other test data invalid. The fourth and final point about achieving parallel test execution is to not be static about static. And it's so funny, I don't see this talked about enough, because it is the easiest way to kill your parallelization dreams. Yes, I know that sometimes you wake up in the middle of the night dreaming about parallelization, and if you implemented the static keyword somewhere in your test automation code, you can say goodbye to those dreams, and now they're going to become nightmares. Here's an example of invalid usage of the static keyword. You can see that here we have a static driver on the second line of code. That static driver means that anytime you try to run in parallel, every single thread will try to use the same exact driver, not different drivers, not different memory spaces, but the same exact driver. So while one test may be trying to open a page, another test will be trying to click a button, and a third test will be trying to type something in, and all of them will be trying to use the same exact driver, and then the driver is going to start doing very weird things. And so your test will start failing in very weird ways. For example, a really good way to know if your parallelization strategy is messed up is if you run a couple tests independently and then they pass, and then you run a group of tests together in parallel, and then they all start failing for weird errors. Like you'll get one error in one test, another error in another test, another error in another test, and then if you rerun it, they'll fail for different reasons. That is a very big red flag that something is messed up with your parallelization strategy. It could be that you used a static word somewhere, the static keyword somewhere, and it's impacting your test automation, or it could be invalid test data, or it could be non-atomic tests, as we talked about before. So avoid the static keyword. It doesn't mean always to avoid it, right? There are some instances where, of course, it's okay, like with strings or loggers or that kind of stuff, but ultimately you should rarely ever need to use the static keyword, especially in construction of your test automation objects. No page objects, no base page classes, no base test classes should ever need the static keyword in them. So if you're finding yourself having to need a static object somewhere in your test automation code, you should really stop and think about whether you're making your test automation code non-thread safe. And I got a couple bonus tips for you guys as well for test automation. Always keep tests quick, right? We already mentioned this, how you want to make sure that your test cases run in 30 seconds max on your local resources. That will allow you to get an extremely fast feedback loop, because in a suite of automated tests, your test suite execution time will be as fast as your slowest test. So if you got 100 tests that run in 30 seconds, but you got one test that runs in 10 minutes, that 10-minute test will make your entire test suite execution time 10 minutes. So if you keep all your tests quick, you don't have to worry about that. And start early with parallelization. Parallelization is way easier to achieve early than it is later. A lot of times we have clients that I work with where they will come to me after they're 1,000 or 2,000 tests deep in their test automation. They come and they say, hey, our test suite is taking extremely long to run. It's taking a day or even 8 hours to run, and we would like to speed that up. And then I say, okay, the best way to do that is with parallelization. There are other ways to do that, like a test optimization, but that's extremely hard and extremely time consuming. So let's see if you can parallelize. And then what we find is they use the static keyword in their framework implementation. In that case, that's it. Goodbye to your parallelization dreams. They can never happen without you refactoring the entire test automation framework. That's why it's so important to start early. Before getting to your third test, what you should do is write your first 2 tests and then make them run in parallel. If they don't run in parallel, you work with your developers, you work with your team until they run in parallel, and do not move on to that third test case until you know you can comfortably run in parallel on your application. One other very important topic I want to talk to you all about is synchronization strategies. Majority of us, unfortunately, to this day, still struggle with the appropriate synchronization strategy when it comes to Selenium test automation. All UI test automation in general, but of course, Selenium being the most popular tool, that's what we're talking about here. You always need to use weights to account for automation speed. Don't forget that automation moves faster than human reactions and internet transmissions. And so using weights to stabilize our automation and to synchronize it appropriately on the correct element, on the slowest loading element, is extremely important. What's even more important is to realize that whenever we're doing local test automation, that is always going to be way more performant than test automation happening in the cloud. First, we all start on local test automation unless we've done automation for any amount of time, at which point we'll automatically start on a Selenium grid. And any kind of Selenium grid is automatically going to introduce latency. That means that before, when your driver.findElement call was taking 50 milliseconds or 500 milliseconds, now it could potentially be taking a second or a couple seconds because it has to travel over the internet. Whether you're using Sauce Labs, Browser Stack, or your own Selenium grid, that is always the case, and that is always going to be a challenge that you encounter whenever you try to scale out your test automation. And that's where synchronization strategy is so crucial. One really cool story I have is I worked with a client recently where they were having a ton of flakiness automation problems. Their tests were very flaky and they were failing randomly, and they wanted some help. I looked at their test code, and by providing them a single easy strategy that I'm going to teach you right here, right now, we were able to have a 2,000% improvement in automation stability. They went from 40 failing tests out of 100 to 2 out of 100 failing tests, just by implementing this one strategy, which is pretty cool. And it's very simple. So let me ask you, what are the types of weights in Selenium? Go ahead, think about it. Well, there are 2, 3, depending on the type of programming language that you are using. In Java, there are 3: implicit, explicit, and fluent. In another programming language like C#, there's just implicit and explicit. There's also, But so implicit, but we're only going to talk about the 2. An implicit weight is where you tell the driver to pull the DOM for a certain amount of time before it throws a no such element exception. It's nice because it only needs to be configured once, right? This was meant to be a global strategy where you set it one time for the duration of the script and you forget it. And the way you set it is right there on line number 2. As you can see, you literally set an implicit weight equal to some time span, equal to some duration, and every single driver.find element will wait for up to that amount of time before throwing a no such element exception. Now that you know what an implicit wait is, I want you to forget about it and never use it. This is the strategy we want you to use in test automation, and what it includes never using an implicit wait. If you have line number 2 anywhere in your code, delete it immediately. The problem with an implicit wait is that it's implemented at the browser level. And so different browsers may provide a different condition for when an element is ready to be interacted with or not. For example, here in Chrome, we try to interact with this one element. You can see that it has an ID, but its style is displayed as none. And if you try to check whether this element exists, if you do a find element on this element here, it will return you the element, even though it is not visible. And the reason for that is because in this case, driver.find element, that's what it checks for, is the element present in the HTML. But in our case, that doesn't matter that the element is present in the HTML. We want to check if the element is visible because we want to check if the purchase was completed successfully. And so in this case, driver.find element will fail when you have an implicit wait turned on. It will also fail with different browsers because, again, as I said, it's implemented differently at the browser level. So instead, what you're going to need to do is to use explicit waits, because if implicit waits are not enough, right, as I already told you, you can't just check an element in the HTML. That's not sufficient. We want to check that an element is displayed, for example, or is visible or is clickable. In that case, we need explicit waits. Explicit waits are the code that we write to wait for some condition before proceeding with the rest of our actions. Now, it could be as simple as the example one you can see here on lines 1 through 4. That is the simplest type of an explicit wait, where Selenium has provided us an expected conditions class that checks for different kinds of conditions, such as element is visible, element is clickable, element contains text, and so on and so forth. That is the easiest way and the recommended way. Of course, you can also write your own expected conditions, as you can see on the example 2 there, lines 6 through 14. There I'm writing my own dynamic wait that will check for an element to be in some specific state. And then the worst kind of an explicit wait is a thread.sleep. You should almost never use a thread.sleep. And I say almost because I can think of one condition where it could be allowed, and that is in some places Selenium types our strings too fast into a field. In that instance, if it's typing strings too fast into a field, there you might use a thread.sleep. What you're going to do is you're going to break down your string into an array of characters, and then as you type one character at a time in between each typing, you're going to have you're going to have a thread.sleep that will wait for 500 milliseconds to slow down the typing of the string. All right, now I know I've given you so much information. This is, as I said before, probably 75 plus years of test automation experience packed into this little tiny presentation meant to take you to the next level, but I want to sweeten the deal even more. I like to give you massive knowledge that's going to take you months and years to implement and improve, but I also want to give you something really quickly so that you can start gauging the quality of your test automation and start working towards these key performance indicators. So here are your key performance indicators that you want to strive towards. For some of you, it may take a couple weeks. For others, it may take years to get to this level. Never stop working towards it. As test automation engineers, as SDETs, it is our job to achieve the highest quality test automation possible so that we can help release software faster that is higher quality. And the way to do that is to strive towards these key performance indicators. You want to have 100% automation reliability in your UI automation. That means that when your UI automation fails, it can either be two things. Either you have a bug in your production code, or the requirements have changed. And that's it. Your test should not fail because of a synchronization, because of a element not found, that kind of stuff. 100% automation reliability. You want to have 30 seconds per test maximum on your local resources in test execution time. We've already talked about that a lot. If you're trying to get a good continuous integration pipeline, 10 minutes max for the entire automation suite. Whenever we are performing in high-level teams that want fast feedback and releasing continuously and daily, 10 minutes is a good amount of time that people can wait before they start getting impatient and complaining about UI test automation. You want to make sure that your tests execute on every pull request, meaning code gets checked in, pull request happens, test automation is running. Test automation should be running every day, almost all the time while people are working. And finally, tests have a maximum of 2 assertions. This will ensure that your tests are pretty much atomic. If you're just striving towards this simple metric, look at your tests. Do they have more than 2 assertions? If they do, they are probably not atomic. Of course, there's way more into that. We already talked about that in depth. But again, these are just simple key performance indicators that you can start applying to yourself, to your automation teams right now, and working towards them one by one, trying to make everything better based on everything that I've presented here. And with all of that, I want to say thank you so much for taking time out of your day to listen to me, to talk about my test automation experience, and to give you my crazy stories, and to babble and to teach you my code. I really appreciate it. I had a pleasure working with you. If you have any questions, feel free to reach out to me. I'm always available. Thanks, and have a great day, and keep automating.